Okay, so here's a question from May 2012, and it's question 5, and it's all about absence in Simon's class. It says Simon is in 9A. The table below shows how many days each pupil in 9A was absent in January. So you've got 24 different pupils, and they've each got a number. So for example, pupil number 11 is a person who was absent for 7 days in January. And then it says, present a frequency table that shows the distribution of the total of absence days in 9A. Now, if you were unfamiliar with that word, Hoepel's-Tabel, frequency table, if you read further on into the next bit of the question, 5.2, they actually show you one. So it can help to read through the whole question and pick up a few clues. But what they're looking for you to do is basically this, a table with the different number of days that people were absent, and then a summary of how many people were absent for each of those days. So for example, there were 5 people who were absent for 1 day, and we can see them in the table, number 1, number 6, number 10, number 12, number 21. So 5 people who were absent for 1 day. Okay, so the marks are quite easy once you know what you have to do. You've just got to count up the numbers in each category and be careful about it. And they all add up to 24, and that makes sense that they add up to 24 because there are 24 people in the class. It says, how large a percentage of pupils in 9A were absent for more than 2 days? Read that carefully. So not 2 days, but more than 2 days in January. So looking at the table, that's basically these ones. So adding those up, it's 3 plus 2 plus 1 plus 1 plus 1. That makes 8. So it's 8 out of the 24, and then times 100 on the top to make a percentage. And that comes to 33.33%. And then 5.3, the frequency table shows the distribution of total absence days in 9B, a different class, in January. So here you've got different numbers of pupils that are absent for various numbers of days. How many pupils were there in 9B in January? So you've just got to add up the total number of pupils. There were 19 pupils, 2 that were late for 1 day, 5 that were late for 2 days, and so on and so on and so on. Sorry, not late, absent for 5 days. So showing that in neat, something like that maybe. Number of pupils is 2 plus 5 plus 5 plus 2 plus 2 plus 3 from the table makes 19 pupils. Question 5.4. Draw a diagram that shows the distribution of the total number of absence days in 9B in January. Well, the simplest way to do that is a simple stick diagram. So on the horizontal axis, I've got different numbers of days that people could have been absent for, and then the frequency, the number of times those different values occurred, on the vertical axis. So there were no pupils who were absent for no days, but two pupils who were absent for 1 day. Let's get that the right way around. 5 pupils that were absent for 2 days. 5 pupils that were absent for 3 days. 2 pupils that were absent for 4 days. No pupils that were absent for 5 days. 2 pupils that were absent for 6 days, and 3 pupils that were absent for 7 days. So simplest possible diagram to pick up the marks in the easiest possible way. Okay, question 5.5 says compare the distributions of the total number of absence days in 9A and 9B with the help of at least 3 statistical descriptors. And then it's got a list of possible things you might use there. Explain with your own words what the comparison shows. Now, during the year in class, I gave you a sheet like this, which is an easy way of just writing the values and finding some of the statistical information, the median, the quartiles, and the highest and lowest values. So it's worth having that to hand. So let's have a look at these. So there's the table of values for 9A, and there's 24 of those. So if I use my median finder, as I called it, and write the values in order, so that's 6 people with no absence days, so 1, 2, 3, 4, 5, 6 zeros. 5 people with 1 absence day, so 5 ones there, and so on and so on. So if I fill the values in, then I'm filling in 24 values in the line that says 24 values, and that immediately points out where the median and the quartiles are. So 9A descriptors was first of all Tupertale. That's called mode in English. It's the one that there's most of. So there are 6 people who were absent for 0 days, and that's more than any other number of people. So the mode, the Tupertale, is 0. It's the most popular number of absent days. Middeltale, also known as Genomsnit, or the mean average in English. It's the one where you add them all up and divide by how many there are. Now, that's quite a confusing name, Middeltale, because you might think that it's the number in the middle, the median, but it's not. It's the same as Genomsnit. And then when you add them all up and divide by 24, you get 2.08. So the value for that descriptor is 2.08. Then you've got the median, and then this little yellow mark on my smart little chart here shows you where the median is. So it's between 2 values that are both 2, so you can say the median is 2. The biggest and smallest values are 7 and 0. They're at either end, you can see. And then that means that the range, Variationsbreite, is 7, because it's 7 minus 0, the difference between the highest and the lowest. And then the quartiles are 0, 2, and 3. That's here, 0 and 2 and 3. They're the cutoff points for the bottom 25% of the data, the halfway point, and then the top 25% of the data. 0, 2, and 3. Let's do the same thing for 9B. So there's the table. It's got 19 people in the class, so using my median finder chart, I'll pick the line with 19 values and write them all in. So there were no people that were absent for no days, but there were 2 people that were absent for 1 day. So that's 2 ones there. There were 5 people that were absent for 2 days, and there they are, 1, 2, 3, 4, 5 people, and so on. So first of all, the mode, Tupertale, well, there's 2 modes, 2 and 3, because both of those groups have 5 people in them, and that's more than any other group. Middeltale, also known as Genomsnit, the one where you add them all up and divide by how many there are. So that's 68 divided by 19, which is 3.58. Median is 3. I can see that just from this. Smallest and largest values, 7 and 1, which means that the range, Variationsbreite, is 7 minus 1, 6. And finally, the quartiles, 2, 3, and 6. So that's clearly shown on my little chart there, 2, 3, and 6. And it's the cutoff points for the middle, that's the 3, and then the top and bottom 25%, so that's the 6 and the 2. So writing that neatly for my final answers, I might do it on a separate piece of graph paper with all of the statistics shown neatly, and then it's a good opportunity to use a box plot because you've got two similar sets of data that you're comparing to each other. So that's an ideal situation for a box plot. And then the comment. Well, I'm looking for two things with a box plot. First of all, the position of the data. So 9b has more absence than 9a. You can see that the bar that I've coloured, or the box that I've coloured blue, is further up the number of absence days. And then the other thing you're looking to look at is how spread out the data is. So I've written that there's more of a difference between the pupils in 9b than in 9a with respect to the quartiles, because there's more spread from the bottom 25% to the top 25% than there is compared to 9a. But on the other hand, you might look at the range and you might think that 9a is more spread out. The important thing to get the marks, though, is the explanation. As long as you write something where you talk about the position of the data and the spread of the data, and you do something to support what you're saying, then you can be confident of getting most of the marks. So that's how I set it out for my final answers, and most of it's just see the separate sheet, see the diagram. So make sure all of those things that are extra are labelled clearly so that the person marking it can find them. And those are the marks: 4, 3, 3, 4, 4.